Okay, final practice final. Here we go. Question 1. Graph g of x equals x plus 2 and its parent function. Then describe the transformation. It's expecting you to graph two things here. The parent function, which is y equals x. This is linear. So the parent function of g of x equals x plus 2. The parent function is just a basic linear function. Y equals x. We start at 0, 0. Because the plus b on the end is 0, so y-intercept at 0. Slope of 1, so over 1, up 1. There is our parent function. Close enough. Now, x plus 2, that plus 2 on the end tells us up 2 from the parent function. So we just take those 2 points, move up 2. And again, big ideas, we'll snap those into place. That's g of x. That's the parent. The graph of g of x equals x plus 2 is a vertical translation. It's on the end. 2 units up from the graph of the parent function. Question 2. Let the graph of g be a translation 4 units down, followed by a reflection in the y-axis of the graph f of x equals x. So we're going to move 4 units down. So we're going to move 4 units down. And then we're going to reflect in the y-axis. Now, y-axis reflections only happen inside with the x. So this is going to be g of x equals negative x minus 4. It's already written there. It ends up looking the same as an x-axis reflection, and that's because linear equations, x-axis reflections, and y-axis reflections look the same. So this is what you'll end up with. If you put something like this, also acceptable. I think big ideas might mark it wrong, but this would be technically the more correct answer. To put it in parentheses, put the negative inside, but then we need to drop the parentheses because we can, because this is only linear, so it should end up just negative x minus 4. But I like it in parentheses. It lets us know what really happened. Question 3, write an equation of a line shown, then use the equation to find the value of x when y equals 185. What we need to remember here is slope formula. Slope is equal to y2 minus y1 over x2 minus x1, or we just look at rise over run. We look at how much do we rise. We rise up 30. We run 2. Rise over run. This is going to give us 30 over 2. So we could use rise over run. It's right in front of us. M is going to be 15. Now, if you don't want to use that and you want to use solely the equations that we have, we need to identify which one's going to be 0.1, which one's going to be 0.2. So we'll go x1, y1, x2, y2. We'll plug that into the slope formula. y2, which is 50, minus y1, which is 20, over x2, which is 2, minus x1, which is 0. Again, 30 over 2, still looking at 15. So regardless of what way you get it, we have a slope of 15. Now, we do have a y-intercept here, 0, 20. That is the y-intercept. We're going to wind up in y equals mx plus b. They've given us the b value. 0, 20. The b value is 20. Y equals 15x plus 20. Now, if you don't catch that on the test and you're scrambling, you can always go point slope. Y minus y1 equals m. x minus x1. And we plug in the pieces that we know. Y minus y1 is 20. We established that earlier. The slope we found is 15. X minus x1 is 0. Y minus 20 equals, we're going to distribute that 15. 15x, we'll add 20 to each side. Y equals 15x plus 20. So, two ways to get to that solution of what is the equation. Now, when y equals 185, we are going to take and trade out y for 185. 185 equals 15x plus 20. Subtract 20 from each side. 165 equals 15x. Divide both sides by 15. 11 is equal to x. So two answers, two answer boxes here. They're going to want you to put y equals. If you miss the y equals for that equation, I will mark it correct. I don't think that's a big deal there. All right, question 4. Describe the transformation f of x equals x squared represented by g of x equals x minus 3 squared plus 4. Inside is left and right. Outside is up and down. Again, inside is left and right. Outside is up and down. This is telling us to go to the right 3 and up 4. Again, vertex form will be on the board. It's been on the board basically the entire semester. So, I don't remember what order this is in, but we'll just assume that horizontal goes first. 3 units right and 4 units up. Those might be swapped. Don't quote me on it. All right. Select the correct graph of each function. So f of x equals x squared. If you look at all of the f of x functions, they're all the same. All of those are the same. It's the g of x's that are different. We're looking for the one that is 3 to the right and up 4. Here it is right here. Let's switch to red. We're going 3 to the right and up 4. There it is. So we went from f of x, which was the parent function, to the right 3, up 4. Let the graph of g be a vertical shrink by a factor of 1/5, followed by a translation 8 units down. Now, we have to do these in order. Now, this 1/5 hits the entire function. So we take 1/5 times f of x, the entire function. So we've got 1/5 times x squared. If there was something on the end, a plus k on the end, this 1/5 will also hit it, but there isn't. So we have 1/5 x squared. And then we move 8 units down. That's it right there. 1/5 x squared minus 8. All right, identify the x-intercepts, vertex, and axis of symmetry of the graph of f of x equals negative 0.25 times x plus 2 times x plus 8. This is intercept form. It gives us the intercepts in it. If we consider this is factored out already. So that means that x plus 2 equals 0, x plus 8 equals 0, x value equals negative 2, x value equals negative 8. That is where the intercepts are. So negative 2 and negative 8. Those are the intercepts. Now we're going to use the symmetry of quadratics. And actually this is going to be flipped over. The a value is negative, so it's realistically going to be pointing down. It should be spread out a little bit wider because, I don't know exactly where this is going to go, because it's 0.25. But here we are. Let's assume that these are our x-intercepts, negative 2, negative 8. We have the axis of symmetry goes directly through the middle, which means we average the x-intercepts. Negative 8 plus negative 2 divided by 2. This is negative 10 divided by 2. This is negative 5. Axis of symmetry, x equals negative 5. Also, x coordinate of our vertex. Y coordinate, we need to plug it in. Negative 0.25. We've got negative 5 plus 2. Negative 5 plus 8. This is negative 0.25 times negative 3 times positive 3. This is negative 0.25 times negative 9. One fourth of 9, that's 9/4. It's going to be 3.75, maybe. Let me grab a calculator real quick. Should have probably had this answer pulled up already. I think this is realistically, I think the most math we're going to end up doing here is on this problem. 2.25, not 3.25. 2.25. I'm super good at math. Okay. 2.25. Let's go ahead and double check this answer because I am known to mess things up. If it will load. Okay. 2.25. Okay, we are good. There we go. All right, solve x squared plus 2x minus 15 by factoring. AC method, a equals 1. Life's going to be easy, a equals 1. B equals 2, c equals negative 15. A times c equals negative 15. B equals 2. Two numbers that multiply to negative 15 that add up to a positive 2. That's going to be a positive 5 and a negative 3. Positive 5 times negative 3 is negative 15. Positive 5 minus 3 is going to be positive 2. Now, these are just the factors. That means that this factors down into x plus 5 times x minus 3, and they're set equal to 0. We need to set each of those factors equal to 0. X plus 5 equals 0. X minus 3 equals 0. Subtracting 5 from each side, x equals negative 5. Adding 3 to each side, x equals 3. X equals negative 5. X equals 3. All right. Just about halfway done. Write the expression 5 minus 8i minus 2i times 2 plus 3i as a complex number in standard form. What we need to remember is that I squared equals negative 1. Because we need to take this negative 2 and distribute it. 5 minus 8i drops parentheses for free because there's no operations in front of that parentheses. Negative 2i times 2, negative 4i. Negative 2i times negative 3i, positive 6i squared. Now again off to the side here, 6i squared is the same thing as 6 times negative 1, which is negative 6. So we've got 5 minus 12i minus 6. Negative 1 minus 12i. Negative 1 minus 12i. Now, again, I'm going to double check that one. It's question 8. I probably should have just left the answers in these ones. -1 minus 12i. All right, write y equals x squared plus 16x minus 7 in vertex form, then identify the vertex. All right, we did go over this. It is not the most fun thing. I'm going to rewrite this. I'm going to leave a gap after y because I need to clear my c term. And then if I have an a term, I need to clear that as well after I clear the c term. I will add 7 to each side to clear my c term. Y plus 7 equals x squared plus 16x plus, since the a value is already cleared, I'm going to leave a blank on the end. We're completing the square. My b value, 16. B divided by 2, 8. B divided by 2 squared, 64. To complete this square, I need 64. And when I add it to one side, I have to add it to the other. Y plus 71 equals x squared plus 16x plus 64. We have a perfect square on the right-hand side. This factors down into x plus 8 squared. On the left-hand side, we still have y plus 71. Now we can bring our 71 back over to the other side by subtracting it. Minus 71. It happens on the outside of that squared. Y equals x plus 8 squared minus 71. That is vertex form. Y equals x plus 8 squared minus 71. Now the vertex it's in vertex form, it's given to us. That plus 8 on the inside tells us to go to the left 8. Minus 71 on the outside tells us to go down 71. To the left 8, down 71, that's where the vertex is. All right, describe the transformation of f represented by g. So we start off with an x cubed, and now we have 2 times x minus 5 cubed. Now, we added an a value in front. That is a vertical stretch because the a value is bigger than 1 by a factor of 2. And a translation x minus 5 on the inside. Minus 5 on the inside tells me to go 5 units to the right. Done. I wish they were all that easy. Vertex form. Okay, question 11. 7t cubed plus 9t squared minus 4t minus 3 minus this polynomial, negative 5t cubed minus 4t squared plus 8t plus 3. We are going to distribute this negative and just drop parentheses from everything and collect things together. What we have, 7t cubed plus 9. Oh, I'm going to fix my plus. I'll make it really small. Plus 9t squared minus 4t minus 3. And now we've got double negative on the 5t cubed, so that's positive 5t cubed plus 4t squared minus 8t minus 3. All right, that's everything. Putting similar terms together, t cubed, t squared. We could have grouped these together from the start if we really wanted to. We will group them together here in a moment. All right, 7t cubed and 5t cubed, 12t cubed. 9t squared, 4t squared, plus 13t squared. Negative 4t, negative 8t, that's negative 12t. Negative 3, negative 6. Now, this is one that I'm going to double check because I'm Mr. Smith, and that's why I make mistakes. 12t cubed, 13t squared, negative 12t minus 6. That looks pretty good. Okay, question 12. Let G be a vertical stretch by a factor of 4, then 3 units to the right of this graph that's given to us. Vertical stretches, A values that are changing, affect the A value of the other function and the K value on the end, the vertical translation. So both of those are going to get hit by the stretch factor of 4. Then once that is done, we move 3 units to the right, which means minus 3 inside. So we're just going to take that minus 2 on the inside. We're going to subtract 3 more. That's going to move us 3 more units to the right. So we have 4 times 3 is 12. This is x minus 5 on the inside because we've subtracted 3 more inside. And then negative 2 times 4, negative 8. Now, if we have translations up and down, we do whatever comes first. So if they tell us to vertical stretch or shrink first, we do it first, then we move up or down. We have to make sure it's in order. There we go. 12 times root x minus 5 minus 8. All right, find the inverse. F of x equals x cubed plus 10. This is y equals x cubed plus 10. Do our inverse line here, swap x's and y's, and solve for y. Subtract 10 from each side. X minus 10 equals y cubed. To undo cubed, cube root. I'm going to write this down one more time. Now, one thing to note, odd roots do not require the plus minus. Cube root and a cube cancel out. Y equals cube root x minus 10 inside. And it's just going to be this piece that goes into the box because it's now g of x. It is a new function, cube root x minus 10. Cube root x minus 10. Expand the logarithmic expression. When we expand, anything that's in the numerator is a positive log. Anything in the denominator, negative log. So this is going to be a positive log, negative log. Natural log of x cubed minus natural log of y squared. And now we need to send our powers to the front as multiplications, and we're done. 3 natural log x minus 2 natural log y. These are ln's. So many of you write in's. It's insane. It's ln. ln. All right. Condensing, we're just doing the exact same thing in opposite order. Sending all of our multiplications as powers. This is natural log 4 squared plus natural log x cubed. They're going to want us to do that 4 squared minus natural log y to the 4th. Now, anything that's a positive log, numerator. Anything that's a negative log, denominator. So, if it's a positive log, numerator. Negative logs, denominators. This is the natural log of 4 squared is 16, x cubed. Those are up top because they are positive. Y to the 4th is in the denominator because it is a negative log. Done. Okay, solving. As long as the logs are the same type and it's just a log is equal to a log, we ignore the logs and look at what's inside. 5x plus 18 equals 12x plus 4. Moving all the x's to the right-hand side, so we're going to subtract 5x. We're going to move the 4 to the left-hand side. 14 equals 7x. Divide both sides by 7. X equals 2. I hope that's right. Good to go. All right. Find the product. These are multiplying straight across. One thing we want to do, factor, if we're multiplying, factor everything that you can, because we're going to have cancellations. Now, 4x squared minus 8x, we're going to factor an x out. So this is really 4x gets factored out. What gets left behind is going to be x minus 2. So we've already factored this. And now we have it multiplying with x squared plus 2x plus 1. This is the AC method. I'll do it off to the side here in a second. But this is going to be x plus 1 squared. It's x plus 1 times x plus 1. But we don't want to have that squared because we want to be able to have cancellations. So let's leave it x plus 1 times x plus 1. Now, in the denominator, we've got x plus 1 times 4x. Let's go ahead and throw some highlights just to show where they're coming from. And blue is going to be our last color. Now, what do we get for cancellations? 4x and 4x, x plus 1 and x plus 1. What gets left behind? X minus 2 times x plus 1. Numbers we aren't allowed to have. X cannot equal negative 1 because that x plus 1. And x cannot equal 0. So x minus 2 times x plus 1. X cannot equal 0 or negative 1. Now the AC method for that, x squared plus 2x plus 1. A equals 1. B equals 2. C equals 1. We're not solving, we're just getting it factored. A times C equals 1. B equals 2. This is 1 and 1. 1 times 1 is 1. 1 plus 1 is 2. We use 1 and 1 for these factors. X plus 1. X plus 1. Okay. Holy cow. Last problem. Solving these rational expressions set equal to each other. Just cross multiply. That's all we got to do. 10 times x minus 1 is equal to 4 times x plus 2. And then we solve. 10x minus 10 equals, I guess we can show some distribution here, 4x plus 8. Let's move x's to the left-hand side. That's where the biggest x is. Numbers are going to the right. 6x equals 18. Divide both sides by 6. X equals 3. And that is it. Okay. That's it. We're done. That's the final. If you watched through this whole thing, good job. Yeah. Good luck on your